Hey guys, Mr. Adamson here. Today this is another lesson in Science 24 where we're going to talk about fossil fuels and the environment. Previous lessons we talked about what are fossil fuels and how to specifically extract fossil fuels. Now the first thing we're going to talk about is combustion. And combustion is a chemical reaction that takes place when a hydrocarbon combines with oxygen. Now a hydrocarbon is a compound that has carbon, and it can have any number of carbons, so that's what that X is going to represent, with a hydrogen. And the hydrogen can represent any number, so it could be, say, C6H12, anything like that. That's those X and those Y's can be anything. So combustion is when a hydrocarbon combines, so plus oxygen gas, and you're always going to get the products of carbon dioxide and water. Now, energy is stored in fossil fuels is converted to thermal energy by combustion. And the other thing that you're going to have on the product side is energy. So again, going back to the combustion, our reactants, hydrocarbon and oxygen, products, carbon dioxide, water, and energy. So as it says here, so as we're saying, in combustion, energy stored in fossil fuels is converted to thermal energy by combustion. So the energy here in our reactants is converted into these products with energy. Now fossil fuel combustion reactions are similar to cellular respiration. So fossil fuel combustion happens quicker though, and produces more thermal energy waste. And again, if you remember back to a previous unit, cellular respiration is how we produce energy for our body. Cellular respiration has glucose as the hydrocarbon with oxygen, producing carbon dioxide and water. We breathe in oxygen, we consume glucose through the carbohydrates that we eat. We breathe out carbon dioxide. We will expel through urination or sweating water, and we're also using energy in the products. And that's where we talked about previously with ATP, adenosine triphosphate. So fossil fuel combustion reactions and cellular respiration, very similar reactions. They are both combustion reactions, but fossil fuel combustion happens quicker and produces more thermal energy. Now, all combustion reactions are composed of a hydrocarbon and oxygen, as I said, in the reactants, and carbon dioxide and water as the products. Now, when fossil fuels are burned, carbon dioxide is released as an environmental pollutant. So that's a big thing here. I mean, we are breathing out carbon dioxide through cellular respiration, but we're not near producing the amount through fossil fuel combustion, not producing the amount of carbon dioxide. So, as we see with the burning of methane, so hydrocarbon here, we are producing carbon dioxide and water. And now this carbon dioxide is really going to come into play through these combustion reactions as an environmental pollutant as we get into later slides. Now, fossil fuels, as I mentioned in previous videos, are a non-renewable resource. So once they are used, they are gone. And the world's energy demand is increasing. And so, I mean, that's pretty interesting that, I mean, a non-renewable resource that we need, that we are producing, or that we're consuming more and more of, is getting less and less. Or we're able to find less and less and mine less and less of it in the environment. And so what we can see here in this graph here, this shows our carbon dioxide variations. And so this goes all the way back to thousands of years ago, and you can see through here there was variations in the carbon dioxide output and the concentration in the environment. But if we look at time zero to where we are nowadays, especially in the Industrial Revolution right here, what this is showing, we have a dramatic rise in carbon dioxide. And that's because in the Industrial Revolution we were developing a lot more machinery, a lot more things that can perform combustion reactions and produce that carbon dioxide. Now what this graph is showing here is the fossil fuel usage per capita. The United States is right up there. Canada is not in this graph, but Canada would be in this area right here. Okay, Germany, Japan, France, where we are consuming a lot of fossil fuels to produce our energy demands. And therefore, this relates directly back to this graph, carbon dioxide concentrations are growing higher. So if we look at a little graph here, our fossil fuel consumption is increasing. Therefore, so is our carbon dioxide output. It's also increasing. But overall, our fossil fuel availability on Earth is decreasing. So because they are a non-renewable resource, so that's an inversely related graph there. Now this slide here shows non-renewable energies. So what are non-renewable sources of energy? So most of, and this is a graph from the UK, so most of the UK's electricity is generated by power stations that burn coal and gas, and our cars use petroleum and diesel, which comes from oil. So what are fossil fuels? Coal, oil, and gas are called fossil fuels. They are formed from fossilized remains of prehistoric plants and animals. And what is the problem? Well, fossil fuels can't be renewed. One day the Earth's reservoirs of these fuels will run out, and scientists think that the gases released when fossil fuels are burned are causing a climate change and the pollution. So we can see all these things here, like the coal that is mined in these mines here to provide energy for our houses, for different stations, different boats, oil and gas, same thing. These power stations, so their electricity is made in big buildings called power stations. They burn coal and oil to make the power, and some of the power stations produce electricity from nuclear energy also, which can be a good thing, but you have to worry about nuclear waste. So, I mean, all these things, our daily life consumes electricity, and that electricity right now is coming from fossil fuels. Now, fossil fuels can cause problems when they are transported, and this can be a pretty serious thing for the environment. So oil spills put marine life in danger. So if marine life swallows the oil, it poisons them. If the oil covers them, it destroys natural insulation and waterproofing, which causes the animals to drown or freeze. And another thing, when you're transporting through pipelines through natural gas, ruptured gas lines can release poisonous gas, which can create breathing issues through smog creation. So if you've ever been to really large cities like the GTA, the Greater Toronto Area, LA, New York, you see smog over those areas. That's caused respiration issues for some people, and other environmental issues such as acid rain. And we're going to talk a little more specifically and show some pictures of acid rain. And so this picture here just is really good, how fossil fuels are starting to cover our planet and becoming deadly to our planet. Now, what these pictures show are a couple of the effects of fossil fuels. This one here shows a bird that has been covered in an oil spill. Most likely, most animals that are involved in an oil spill are high chance of non-survival. And then this picture over here shows acid rain formation. So coal-fired electric utilities and other sources that burn fossil fuels emit sulfur dioxide and nitrogen oxides and carbon dioxide. And what these gases do, along with CO2, and CO2 is one of the major ones, when they combine with the atmosphere, what they start to produce is acid rain. And this acid rain goes over the environments. You'll see burning in some of the grasses. It becomes toxic in the lakeways and rivers. It becomes toxic for fish. These fish die. Some animals eat them. Becomes toxic to the animals that eat the dead fish. So it can burn the skin of some animals. So it's a vicious little cycle that is happening and starting to destroy our environment. Now, burning fossil fuels has led to an increase in greenhouse gases. Now, greenhouse gases trap heat in the Earth's atmosphere, making it warmer. Now, scientists predict that some places will get much warmer while others will get cooler, and this is called the global climate change. So this is what their prediction is. Now, the effects of global climate change include less precipitation, which may lead to new deserts being developed, polar ice caps melting, and this may cause flooding in low-level areas, especially in areas like you think Florida or coastal areas where they are low to the ocean level. As these polar ice caps are melting, the sea level, the ocean levels rise, you get localized flooding in certain areas. So I mean, these greenhouse gases are a pretty serious thing. They're affecting our environment right now. This shows here, these pictures here show a couple different things. This first one right here has two sides, has a natural greenhouse effect and the human enhanced greenhouse effect. The first one, the natural, shows how we have solar radiation coming in. It is reflecting off the Earth, and now we have some greenhouse gases out in our atmosphere. Now this leads, though, when we have less, you have more heat that is escaping into space, and this is not the end of the world. However, through the human enhanced greenhouse effect, we have a larger area of greenhouse gases in our atmosphere, and as that solar radiation comes in and reflects back off our Earth, it can't escape that atmosphere, and therefore we have an increased heating over our whole planet. We can see here we have gas production, and the big part here where carbon dioxide is coming from, you can see carbon dioxide from fossil fuel combustion is comprised of 82% of all carbon dioxide within our atmosphere. And then this last picture down here is just showing how the sunlight passes through the atmosphere and warms the Earth. The infrared radiation is given off by the Earth, and most infrared radiation to the outer space escapes to outer space and helps keep the Earth, cool, not too cool, warm enough, but in a right stable temperature. But if we look at point 3 here, some of the infrared radiation is trapped by gases in the air, and this reduces the cooling effect. So that's starting to contribute to the global climate change effect. And that's it for now. So I hope you enjoyed listening and were able to take something from that. And until next time, thanks for listening.
Made with Doodlecast Pro.